So the International Space Station these days, an unparalleled laboratory, a lot of research happening around the clock on board. Obviously, some of the greatest minds in the scientific community getting involved, but also a lot of great chances these days for the scientists of tomorrow's, the up-and-comers coming through school to get their research actually on board the International Space Station. So today we're going to learn a little bit more about that. I'm joined by Dr. Jeff Goldstein, who's the director for the National Center of Earth and Space Science Education, and they're currently operating the Student Spaceflight Experiments program, one of these great opportunities to get students involved at an early age, get them excited about scientific research, and then see some real results. So first off, Jeff, thank you so much for joining me. I really appreciate it. And if you could start us off, maybe just tell us a little bit about the center and what the Student Spaceflight Experiments program is looking to accomplish.
Well, really great to be with you this morning over here. The center oversees the creation and delivery of large-scale national science, technology, engineering, and math programs, which is the familiar acronym STEM. And the two core goals are to provide students in general an understanding of how science and technology works. It addresses science literacy at the most fundamental level. But it's also about inspiring and engaging the next generation of America's scientists and engineers and really getting them excited using the Earth and space sciences as the vehicle. We also offer programs like the Student Spaceflight Experiments program internationally to communities across the world through our international arm, which is the Arthur C. Clarke Institute for Space Education.
All right. Well, again, it's great to hear about just these opportunities are out there, and obviously we want to get as many students involved as possible. And it's a pretty exciting time for you guys. You actually have 18 more experiments getting ready to fly on the next orbital vehicle. Real quick, just tell us a little bit about some of the important research that's going to be going up. What are the important things we want to know about that? The next load on its way up?
Well, the Orb-3 vehicle is carrying the Yankee Clipper SSEP experiments payload of 18 experiments. And what's interesting is that each one of these SSEP missions engages a number of communities, in this case 18 communities across the US and Canada. And these students are immersed in a real formal research competition. We've got, in the case of this upcoming mission, 6,860 students that were fully engaged in microgravity experiment design and proposal writing. And that led to 1,487 proposals from student teams. And we then culled that down so that the Step 2 National Review Board selected one flight experiment for each of the 18 communities, and that's what's flying. That's what's going to be flying on Orb-3. And so each of these experiments represent hundreds of students across that community that were vying for that experiment slot, and hundreds of students absolutely immersed in authentic experiment design and proposal writing. What's also kind of interesting is that this program is grades open to grades 5 through 16. So it goes from upper elementary, grade 5, right through 2-year and 4-year colleges and universities. So it really provides a very great pipeline approach to this immersive experience. And I can tell you that we've got 3 of the 18 experiments from the upper elementary level, 9 from middle school, 5 from high school, and 1 from 4-year colleges and universities. So you asked about the kinds of science that are being performed on orbit through this mission 5, actually mission 6 to ISS. It's a whole range of science. The students have the ability to design microgravity experiments in a science discipline of their choice, but must be constrained by the operation of the real mini laboratory that they must use. And so we have experiments in crystal growth, efficacy of composting in microgravity, lots of bacterial studies, including the growth of coliform bacteria, the efficacy of biocides on bacteria, the efficacy of E. coli attachment to food, growth and development of mosquitoes and houseflies, seed germination and geotropism studies, hydroponics, studies of microaquatic life, in this particular case, the development of fairy shrimp, and also there's an experiment, an elementary experiment on the rate of food spoilage. But maybe it would be nice to highlight 2 of these experiments, which are, I think, quite remarkable. The first is North Charleston, South Carolina. They're on their second SSEP opportunity. And we've got a high school team that is looking at tin whisker development in space, which are these metallic crystalline structures that grow on printed circuit boards. It's a serious problem in space. Mm-hmm. And they've been working with a number of NASA researchers as advisors on this. What's interesting is that they proposed a year ago and got to the finalist level, but didn't get selected for flight. And based on the strength and weakness comments from the review panel, they resubmitted, they corrected some of the issues, and now they're a flight experiment. So this is how real research is done, and these high school students are experiencing that. The other one to mention is that the American University is leading a 2- and 4-year consortium of 7 colleges and universities in the DC metro area, and there the students are undergraduates that are studying to be science teachers. And so the idea was to immerse these students in real research so that they can have a better understanding of how science and technology work, and that would translate into remarkable capability inside the science classroom for them.
And so, I mean, just wow, really hitting kind of the full gamut, getting the same experience as you said that actual researchers are getting, and just, I mean, the range of ages is very impressive. So real quick before we close, how can students get involved with this? Is there a website to go to? What is the best way to, for if any student watches this, to go get their teacher and say, hey, I mean, this is something we want to do?
Yeah, the Student Spaceflight Experiments program has a dedicated website. So if you go into your browser and put in SSEP or Student Spaceflight Experiments program, you can go right to the website. We've got Mission 8 that was just announced last week, which is our 10th flight opportunity in, believe it or not, just 4.5 years. And we are now talking to communities across the country. In fact, we've got a lot of communities in Canada that are interested in starting program operations in February of 2015 with a flight to ISS in the fall of 2015. So if any communities are interested in figuring out how they can come aboard and get their own very real space program, they should go to the website. And I should also, by the way, say that this is a remarkable effort that is enabled with this wonderful Space Act agreement between NASA and NanoRacks. And this is a commercial space venture that is enabled through that commercialization on orbit. And we are also working in partnership with the Center for the Advancement of Science and Space, which runs the U.S. National Laboratory on ISS. So this is what partnership is really all about.
And it's always great to see those partnerships come to fruition, especially when it means inspiring the researchers of tomorrow and getting them on board. So again, Dr. Jeff Goldstein, the director of the National Center for Earth and Space Education, talking to us about Student Spaceflight Experiments program. Get involved, follow along. It's a really great program. Jeff, thank you so much for joining me today. I really appreciate it.
You're very, very welcome.